In this video, I've put some practice questions on mechanical comprehension for you to prepare for the ASVAB test. What are the components of a lever? Fulcrum resistance arm and effort arm, a point of origin and solid plane, resistance arm and effort arm, a wide plane fulcrum and effort arm. The answer here is this one: fulcrum resistance arm and effort arm. So the three key components to a properly functioning lever are a fulcrum, an effort arm, and a resistance arm. While a plane is a component of levers, this is not strictly necessary. A variety of implements may be used to create a lever effect. What determines the speed of an output gear? The speed of the input gear and the ratio of the number of teeth on each gear, the size of gears. None of these. Gear speed is not capable of alteration, or the ratio of companion gears. The answer here is this one: the speed of the input gear and the ratio of the number of teeth on each gear. What are the potential functions of gear systems? Gears possess a single function, transmitting motion. Gears are primarily used for making changes in speed, but may also be used to instigate motion in machinery. Gears may be used to change direction in machinery and can be used to increase speed. Or the potential functions of gears are changes in direction, speed changes, both increases and decreases, and motion transmission. The answer is this one. So these are the potential functions of gear systems: changes in direction, speed changes, both increases and decreases, and motion transmission. If a mechanical device is reported to have an advantage of 2, what does this mean? The numbers are assigned to demonstrate the force that can be exerted using the same amount of effort. So 2 here denotes twice the force, or 3 triple the force, and so forth. So the amount of work completed remains the same. The answer here is this one. So this means that the device allows users to exert twice the amount of force with the same amount of effort. An inclined plane is a commonly used implement and has many applications, including handicap access. What is the most common name for an inclined plane? The answer here is a ramp. The only other applicable name is ramp. Inclined planes or ramps are commonly used as handicap accommodations, including coverings for stairs and curbs. How can workers increase the mechanical advantage of pulley systems? Using a higher platform for the load in need of lifting, using additional pulleys to further distribute weight, using longer stretches of rope, or decreasing load size and weight. So the answer here is this one: using additional pulleys to further distribute weight. Longer rope and higher platform will not alter the mechanical advantage of a pulley system, while decreasing size and weight will undoubtedly assist in lifting. This does not increase the mechanical advantage. The only means of increasing the advantage is through implementing additional pulleys in a pulley system. The best definition for drag is a responsive force that only affects movement on a solid, a responsive force that affects the movement of an object through a fluid, the internal stretch force of a material, or a responsive force that only affects movement in air. The answer here is this one: through a fluid, a responsive force that affects the movement of an object through a fluid. So drag occurs when an object moves through a fluid like water or air, and friction occurs when 2 objects touching each other are moving at different speeds or in different directions from each other. The internal stretch force is referred to as tension. In which direction does the friction act on this skier? So based on the figure here, the skier is going downwards, where friction is a force that resists the sliding or rolling of one solid object over another. In here, the skier is going downwards, therefore the direction of the friction is opposite to it. So the direction of the friction is going upwards. Therefore the answer here is D. You're using a 6-inch wrench to release the wheel nuts as you rotate your tires. If you're applying 40 pounds of force, how many torque is on the wheel nut? Now to solve for torque, this is just equal to the pounds of force times the length. Okay, in this case, the length is 6 inches. But among the choices, we don't have inch here. We only have feet. So we need to convert inches to feet. Now 1 foot is just equivalent to 12 inches. Therefore 6 inches is just equivalent to, we divide this by 12. This is just equal to 1/2 of a foot. So 1/2 foot. Now we can solve for torque. That would be 40 pounds of force times 1/2 foot. This would give us 20 foot-pound torque. So the answer is this one. And by the way, the 6-inch length here is the radius of the lever arm, and we just multiplied it to the force applied. And the other unit for torque is Newton meter, which is just equivalent to foot-pound. Torque involves a perpendicular force applied to a lever arm that moves around a center of rotation. Increasing the length of the lever arm will do which of the following: increase applied force, decrease torque, or increase torque. The answer here is increase torque. How much force is needed to lift the 10-kilogram weight? This figure here shows us a double pulley system. In a double pulley system, the force is equal to the weight divided by 2. So the weight here is 10 kilograms, and divided this by 2, this would give us 5 kilograms of force to lift a 10 kilogram weight. So the answer here is 5 kilograms. If a wedge is made longer relative to its height, how does the force increase? The amount of lift is increased as the wedge is moved vertically. The amount of lift is increased as the wedge is moved horizontally. The amount of lift is decreased as the wedge is moved horizontally. The amount of lift is decreased as the wedge is moved vertically. The answer here is the amount of lift is decreased as the wedge is moved horizontally. So a wedge converts horizontal force into vertical lift. Its effectiveness is influenced by its length and height. When the wedge is made longer relative to its height, meaning less steep, the slope decreases. So this means that for the same horizontal distance moved, the vertical lift decreases. Since the vertical lift is reduced, you need to apply a greater input force to achieve the same lifting effect. Therefore, the amount of lift is decreased as the wedge is moved horizontally. A 6 kilogram bowling ball rolled at 2 meter per second expends how much work? So work equals kinetic energy, and this is just equal to 1/2 mass times the square of the velocity. So we're given here the mass, which is 6 kilograms. We just plug that into the equation, times the velocity, which is 2. Let me write that down here. So work is equal to 1/2 mass 6 kilograms times the velocity, which is 2 meter per second squared. So this is just 1/2 times 6 kilograms times 4 meters squared per second squared. So multiplying everything, this would give us 12 kilogram meter squared per second squared, or joules. So 12 joules. Therefore, the answer here is this one. An axe is an example of what type of simple machine? Wedge, inclined plane, lever, or none of the answers. It is a wedge. An axe is a classic example of a wedge.